Earth's ocean holds roughly 97% of all the water on our planet, and almost every single drop of it is an entirely undrinkable brine. Yet this massive body of saltwater is constantly being fed by freshwater. Every single day, billions of gallons of fresh rain and river runoff pour directly into the ocean basin. This graph illustrates the mathematical paradox of that process. Over billions of years, this unrelenting, massive influx of freshwater should have completely diluted the ocean. Instead, the salinity metric refuses to drop. That paradox exists because our basic assumption is backwards. Rivers are not diluting the ocean at all. They are actually the primary delivery system for the salt. The ocean is not a static puddle left over from Earth's formation. It acts as the central collection basin for an active, global-scale chemical processing plant. The process starts high in the atmosphere. As a single drop of rain falls through the sky, it picks up carbon dioxide from the surrounding air. That interaction causes a subtle chemical reaction. By the time the water hits the ground, it has transformed into carbonic acid, a naturally, mildly acidic rain. When this acidic rainwater lands on solid mountain rock, it physically strips away microscopic layers of the stone. This slow weathering releases specific mineral ions from the rock, most notably sodium and chloride. You might wonder why rivers still taste fresh if they are full of dissolved rock. The answer is flow. Rivers are highly mobile transit systems, constantly flushed and refreshed by new rainfall and melting snow. The dissolved rock never has time to build up. Instead, these invisible payloads of dissolved sodium and chloride are carried along by the current, flowing continuously from the interiors of the continents straight down into the ocean. Through this constant weathering, the physical mass of the mountains is slowly being transferred, atom by atom, directly into the sea. But the land surface is only half the equation. Massive amounts of minerals are also entering the water from miles below the seafloor. Down at the bottom of the ocean, the crust is highly geologically active. Freezing seawater seeps deep into cracks in the ocean floor, traveling downward until it reaches the intense heat of underlying magma. The magma superheats the water, triggering a violent chemical exchange. The boiling fluid reacts with the surrounding volcanic rock, dissolving an entirely different set of heavy minerals, including iron, zinc, and copper. That superheated, mineral-rich fluid is then blasted back out into the open ocean through deep hydrothermal vents. All of these minerals, from the mountain runoff above and the volcanic vents below, converge in the ocean. And unlike a river or a lake, the global ocean basin is the absolute end of the line. It has no physical outlet for dissolved solids. The only way water leaves the ocean is through evaporation. But as the sun lifts water from the surface to form clouds, it only takes pure H2O into the atmosphere. The heavy, dissolved salts are left completely behind. By combining massive global mineral inputs with an evaporation trap that never lets those minerals leave, the system forces a relentless, one-way concentration of salt over billions of years. Which brings us to the ultimate mathematical crisis of this system. If billions of tons of salt are always entering and only pure water is leaving, the ocean should be an entirely solid block of salt by now. Since it is still a liquid, there must be a missing variable. The ocean possesses hidden outputs, natural mechanisms that actively remove salt from the water. The first is biological. Countless marine organisms, from massive coral reefs to microscopic plankton, continuously pull dissolved minerals directly out of the surrounding seawater. They consume these specific dissolved elements, particularly calcium, using them as the raw building blocks to construct their solid organic shells and skeletons. The second mechanism is purely geological. Independent chemical reactions in the water force other dissolved minerals to crystallize. They fall out of solution, raining down to eventually coat the seafloor as solid rock sediment. This chart shows the complete chemical loop, illustrating a state of dynamic equilibrium. The exact volume of new salt entering the water from rivers and hydrothermal vents perfectly matches the volume being locked away by biology and sedimentation. The salinity locks into a stable, flat line. Because the amount entering strictly dictates the amount leaving, this precise chemical balancing act has successfully maintained the ocean's exact chemistry for millions of years. The salinity of the ocean is the measurable output of a perfectly balanced planetary heartbeat. It physically links the falling rain, the eroding mountains, erupting deep-sea volcanoes, and living biology into a single continuous cycle.